Okay, hey everybody, my name is Mr. Brown, and today am talking about three things, translate, rotate, and reflect, but they all fall under the category of transformations. Transformations is things that you can do to an object, like this. You can slide it around, or you can rotate it, or you can, reflect it and make it look backwards. So, with these things you have the translate, you have the rotate, and you have the reflect. So, translate. It is literally like a push. You are pushing it from here to there, or you are pushing it from there to there, or anywhere up like that. Okay, but it always, like if this line were to stay, I guess you can see it, if this line were to begin being horizontal, then anywhere you move it, it's still going to be horizontal. And that's how you translate all of these points. So if you move X at 5 points, then that means everything else is going to be moved 5 points. Now, rotate is a little bit different. Rotate is about a fixed point. So like my elbow. If I am rotating about my elbow, I'm going to take this shape right here, and I can rotate it like so. That is considered a rotation. So if you'll notice, this line here horizontal, not horizontal anymore. That's the way that works. But it's only rotated around a point. Now, a reflection, everybody thinks reflection is the mirror, right? So think about that. If I have a line like so, here's actually a better line. If I have this is my line and I want to reflect it, I take it here and I reflect it about there. So you would always see, if you can kind of see in the back of this, so here is this, and then reflect would look like that. So that's reflection. Okay, now, so in short, this is how it works. Let's say that I have some sort of coordinate, and I go 1, 1, 2, 3, 4. So my point A is at a 1, 4. Now I want to move point A, so I want to just move it. I want to slide it. So what is that going to be? Yep, that's right. It's going to be a translate. So I'm going to slide point A, and I'm going to slide point A over to a 3, 0. Now this point came from this point, so this is not, I can't put a B or a C or a D or F or my house or anything like that or X. I have to put where it came from. So it came from A, so therefore it's an A prime. Now that means that this thing right here is what is called a pre-image. It sounds weird. I wish I could have been the first person to make it up, because I would have called it something else. But this is called a pre-image. If this is a pre-image, what do you think this is? You probably got it wrong. Actually, it's called an image. So weird thing, this is pre-image, this is image. So we move there. Okay, so if I'm going to write something generic, what happens from A to A prime? Well, my X's and Y coordinates, okay, it goes to, I don't put an equal sign. If you notice, I wrote that equal sign out of just kind of, what do you call that? Out of a pattern, out of, habit. Yeah, thanks. So, thanks for that. That was good. Right there. Okay. So, this right there means it goes to. Okay. So that's a different math sign. In math, you'll see like an arrow, or even a double arrow, or you'll see arrows going back and that forth. You'll see equal sign, congruent. So this time you have an A prime. So A prime has been declared from A. And what happened to your X? Your X went from a 1 to a what? To a 4? Now your X went from a 1 to a what? It got shoved over 2 places. So that means it increased by 2. So I'm going to take my X and I'm going to increase it by 2. Now, what about my Y's? My Y's started out at 4, and did my Y's increase or decrease? Looks like they decreased, but how much? My Y started at 4, and then it decreased by 4. So therefore, Y decreased by 4. So that is the formula that I have to use on this graph. Everything on this graph is going to be translated at the same rate that A was. So if I pick B over here, let's say that B is right here. So 1, 2, 3, 4, 5, 6, 2. So B right here is a 6, 2. So if B is a 6, 2, then B's X, Y, what is B's X? It is a 6, 2. So since that is true, B prime would wind up with what coordinates? Well, I have to move it down and across, or right and down, the same way that I moved A to A prime. So B, so what rule do I follow? Well, here's my X, right? So what do I do with that 6? I add 2, that's right. So 6 plus 2 is 8. Good. And then I take my Y. My Y is 2, and I subtract 4. 2 minus 4 is negative 2. So I would have to plot B at 1, 2, 3, 4, 5, 6, 7, 8, and then a negative 2 down here. So that right there is my B prime. So that's how it works. So if you will look in your book, on the online textbook, on page 52, page 52, okay, you can pause the podcast right now and you can find on page 52, and there is a number 3. I'm actually going to bring it on my projector right quick. Hopefully it will work. Yeah, so here we are. So I'm going to erase all of this, and it says find the coordinates for the image of JKLM after the translation. Pause for just a second. I'm going to make sure that it's still on. And we're still cooking with bacon. So I like bacon. Alright, so find the coordinates for the image of JKLM after the translation. So here's the shape. If you can't see it, JKLM. So here are the coordinates. And then you're going to have to find the coordinates for the image. Now, what does that make this shape right here? Is this the image? No, it's not. What is it? It's the pre-image. Kind of strange, I know. So now we're going to be moving it to its image spot. And this is how we move it. So this is the pre, and this is the image. So how do I move it? Well, I take my X and I subtract 2. So for point J is at a what? A 1, 1. So 1, comma 1. So arrow notation, that's what that's called, arrow notation. Arrow notation says that J prime would be at what? Well, 1 minus 2 is a negative 1. And then 1 plus 4. That's at a 5. So I'm going to draw with a little bit different marker, and I'm going to plot J prime at a negative 1, 5 right there, and I'm going to call that J prime.